kind of get an idea of what we're talking about. So you asked how to kind of get a general idea on how to take a a closed sketch and then have some sort of path or profile or path, excuse me, pierce that sketch. So what I'm
Yeah.
going to do here is I'm going to just create a really basic sketch. I'm not even going to bother smart dimensioning it. There's really no reason to. And the basic idea is that we really, at least generally speaking, we don't want any other, or rather our path to be, I guess, coplanar. So to kind of explain that, I don't want to just pick another point that's already on
Mhm.
the top plane, just because it doesn't really help us that much to do that, since you could have already done that on the base sketch anyway. So I would
Mhm.
typically try to choose either another plane, whether it be the right or front, or rather whichever primary plane you didn't use, or a datum plane that you may have created in order to sufficiently create your path. So I'm just
Mhm.
going to do the front just because I'm feeling like it. And I'll sketch on this a little bit. So I'm just going to make this kind of crazy. Why the heck not? And then I'm going to make sure that it at least is kind of close. It doesn't have to be exact because what's nice is that once we assign the relation, it will fulfill that task already. So what I'm going to do while I'm still in the sketch menu, or in the
Mhm.
sketch for the path itself. So that's kind of important because generally speaking, you can't really easily assign relations when you're not already in a sketch. So what I'll do is I'm going to click it as very end point of that sketch, and I'm just going to click on the edge itself. And nicely enough, you'll see on the left-hand side, the only relation that
Okay.
we can possibly assign is going to be pierce. So that just means
Mhm.
that SolidWorks understands that the line in question, or lines, or sketches, what have you, are technically not coplanar to that original sketch. I guess the
Mhm.
best way to think about it, uh, wish I could like literally, I mean, I could go on cam or anything like that, but it's not really necessary. Think about taking like a piece of paper and then just jamming a pen or pencil like right through anywhere
Mhm.
on that paper itself. It's piercing the paper at some given point. Now, obviously, it's easier if it's on an edge because those are defined as opposed to some random point on this plane itself, which I could do,
Mhm.
but less necessary to do. So really all that's happening is it's just understanding, hey, this is going to be right on the edge of that plane, and it's going to pierce that profile itself. So in one manner or another, it's effectively saying that it is part of. I don't want to say the plane because they're not coplanar, but it's kind of part. They're connected or they're linked up in some manner
Right.
or another. And that's generally speaking what you want to do for these. Sometimes it might assign or ask you if you want things like coincident or midpoint. I would be much more careful about midpoint than coincident. Coincident is fine. Usually it will accomplish the same goal. Midpoint,
Mhm.
depending on where that sketch curve or path might be, and depending on what you are trying to do, might mess things up. And the reason I say that
Okay.
is because we might not always want our profile to be uh, exactly at the midpoint of that edge. Perhaps when we're using some of the more complex functions, uh, we might want it to be at least more on one side than another. So obviously that would be a little bit more complex. That would require us to use things like datum planes to make sure that it is off center. But I mean, heck, even if you look at it right here, it's already aligned with the midpoint. That's why midpoint is sometimes acceptable. Coincident is usually pretty good. Pierce is going to be your, I would at least argue, your gold standard when you're trying to do these. It's going to yield generally the best results because then it understands, okay, these things are locked in place. That kind of makes sense?
Oh yeah, no, definitely. Thank you.
Yeah, no problem. Okay. So unless there's anything that's much beyond that, On my end, specifically for the recording, I'm going to hop on over to the lecture review. I'll still have SolidWorks pulled up, just as part of like the stream, just in case I want to flip over and do anything specific, or if you guys have any questions about anything specific. But I'll primarily be just going over the PowerPoint itself. So hopefully you guys are able to follow along kind of on your own. And then any other kind of points of clarification, we can definitely hop on over to SolidWorks and clear those up. So first couple slides are really just about general housekeeping, and what I mean by that are, since we have the exam coming in or coming up tomorrow night, there are a good handful of things that I want you guys to keep in mind other than just features themselves. So the first of which is that, and I know I've been harping on this pretty much all semester, and then when we went over sweep and loft, that kind of went right out the window. But by and large, you're going to want to always fully define your sketches. So fully defining your sketches can be, or rather can consist of making sure that you yourself are assigning all of your measurements via smart dimensioning. However, there are times whether you're having some difficulties making sure that everything is fully defined. Maybe you just know that the measurements are correct and you don't want to basically reassign them, kind of like when you assign the measurements on the left when you first create a measurement. You can say, hey, this is supposed to be 1 millimeter, but that doesn't necessarily mean that it's fully defined. So make sure anytime that whenever you are creating these sketches, make sure that they're fully defined in more instances than not. It's a great way to make sure that everything is locked in place, nothing is being moved around in an inappropriate manner, or when you possibly change one measurement, the entire thing goes all out of whack. That has been known to happen. It's happened to me. It's probably happened to some of you guys before. It will happen just as a result of playing around with the software. It's not a bad thing. Definitely make sure that you guys are kind of paying attention to that. I hate to put it so bluntly, but and I but I've already been doing it throughout the semester and kind of at least steadily making sure that if stuff isn't fully defined, I'm sorry, but you guys are going to get docked with regard to points for that. So I don't want to do that clearly, but it's just a factor of kind of making sure that everything is kind of sound for those sketches. So make sure that you are using that fully defined sketch option. It's a great way of making sure that everything will be fully defined as it should. And I personally will make sure that if there is any instance where things shouldn't be fully defined, in cases of using certain sweep and loft functions, I'll try to remember that as well. Because, I mean, like I said, I've been harping on it so much for you guys. I would hate to dock points when I'm the one who told you not to do it. Um, Beyond that, another thing that I've been saying super often, but there's tons of different ways that you can create all of these geometries. So as the saying goes, there's many ways to skin a cat. So as we can see on the left-hand side here for this next slide, we basically see two stacked cylinders of both different radii and of different height, different depth values. So I mean, it is very much up to you guys to make sure that not only are you figuring out possibly the best way of approaching a problem, but just what you think works best as well as what you're most comfortable doing. I said it multiple times that there's ways that, or there's stuff that you guys have done already with regard to some of your homeworks where I look at it and I'm just like, I had no idea that you could do it that way. I mean, I'm just grading like homework 3 right now, the one with like the three screw holes kind of like in a circular pattern. I had no idea that you could just say, hey, I'm just going to pick like 3 points, make sure they're aligned properly, just using the hole wizard one single time. I was under the impression that you would kind of have to use it several times or use a pattern. So, and I'm seeing most of you guys use it, so I'm the odd one out looking at it thinking, wow, I didn't even think about that. That's awesome. But in terms of kind of the question that I posed here, we have this geometry that's on the right here. what are two or maybe more ways that we could possibly create a geometry like this? Does anybody have any thoughts or ideas? Any ideas whatsoever?
No, I'm not sure.
The first one, well, it could just be two different extrusions.
Exactly, yeah. You could think about it
That'd
as
be like the
just
simplest way.
two circular extrusions. I mean, it's literally just two cylinders that are stacked on top of one another. So it's really not that crazy in terms of what you might have to do in order to create something like that. Can anybody think of another way that you could possibly create something like this?
You could revolve it like extrusion.
It,
Hmm.
exactly. I mean, those were exactly the two things that I was thinking of. You could do a revolve. You can also do an extrusion. So obviously, it's six of one, half a dozen of the next. You can do these things however you please. Um, to one person, it might be easier to do it the revolve way. To another person, it might be easier to do it in an extrude manner. I mean, if you think about it like this, an extrusion is going to take up two features, whereas a revolve can feasibly take up just one, considering this right here does have radial symmetry to it throughout a central axis. So I mean, this is probably one of the more rudimentary examples that I can give you, just showing there's at least two ways of doing it, and I can guarantee you there's probably about 20 more that I'm not smart enough to think of off the top of my head. So there's so many different ways that you can create stuff. Um, Beyond that, make sure you guys are assigning materials. So I've harped on it a whole lot, and you guys have been getting pretty good about it. So I'm happy to see that. And I don't really want to say that things are meaningless uh, without a mass, but not only is it just good practice to assign a material always, presuming you know what the material is, uh, but assigning a material can also benefit you. I don't want to pose it in a manner such that you guys kind of think about it as like, here's one extra thing that I need to consider or else I'm going to lose points. I want you guys to kind of think about it in the sense that the mass properties option and assigning materials is a great way at checking your geometry as a whole. If your geometry is sound and it's pretty darn close to what I have as well, chances are your mass value is going to be no more than a gram or like a tenth of a pound, or maybe give or take a fraction of a pound plus or minus what I already have. I mean, I'm already looking at some of the examples. There's been like a couple homeworks where I've seen some of you guys get more uh, consistent mass measurements than I have, and the same people are getting tens, or maybe they're getting like the geometry totally correct, and I'm just sitting here thinking like, what did you guys do that I didn't do? Like, or rather, like, where's the discrepancy? Like, I'm not going to dock a point for that because I'm looking at everything and I'm seeing, okay, the mass is like a tenth of a gram off when we're already in like tens of or maybe hundreds of grams. There's no reason for me to take off points when it's like that small of a discrepancy. Obviously, if it's like 1 or 2 grams, that might be some cause for concern. But I'm more concerned about making sure that your geometry looks sound and that all the measurements are correct and the material is assigned, as opposed to is the math to a or is the mass to 100th the same as mine? That's ridiculous. I hope there are no professors who are doing that, and any who are, God help those students. Um, Beyond that, so understanding symbols, as well as checking measurements. So pretty few and far between, but generally speaking, you guys are pretty good at making sure that your measurements are sound. and are the correct measurements that they should be. The more important thing is kind of understanding a lot of the symbology and what certain things mean. Obviously, we're looking at about 5 different things here. There's way more. Like, heck, when I was going through the PowerPoint and when I was kind of adding more things to make sure there was little diagrams here and there, I was finding more things, and I'm just like, I can't pack this slide full of everything that's here. So just kind of be cognizant of what certain symbols mean and being able to interpret them carefully and accurately, just so that you're not staring at it during the exam and saying, I don't know what that means, and it's gonna kill my ability to do this part. So just make sure you kind of have a good interpretation of what everything means. And then on the following slide, at least for these 5 examples that I gave here, I just listed specifically what they were. So generally speaking, when you see something like a 4x, that's typically saying that that measurement is being replicated for 4 different things or x number of things. In this case, anytime you see an r, you should always think radius. Anytime you see that circle with a line through it, I know it kind of looks like a Greek letter, phi or phi, that's always going to indicate diameter. The line that kind of looks like a symmetry line, that's another good thing that I should have added, but c'est la vie. Symmetry lines are, in this case, with the kind of arrows on the end, indicates that a cross section is being taken. So I always think about it where you see an example like that, where the arrows are pointing to the right, is basically you are looking at the cross section as if you were staring at, I guess you could say, technically speaking, the left side of the object, but you're staring in the right direction. So those arrows are not just there for show, they're indicating the direction at which you are seeing that cross section. So there is a reason for that. So I guess if you're kind of thinking about it in terms of like a rotation or clockwise versus counterclockwise, you would basically be rotating it counterclockwise. So you're kind of looking at it as if you can kind of see that front face where those curved out, like where that curved out pentagon or cut out pentagon is being shown. That downward arrow with the line on top, that typically is an indication of depth. And then the very last one, anytime you see kind of that circle, that circular view, and then it'll typically say detailed view, is just giving you a blown up image of something of importance. So in a case like this, I mean, this is, for those of you who are probably scratching your heads about this, this is homework 5. So all I'm doing here, or all the idea here, is that it's pretty much just saying, hey, I want to get a better view, so I'm going to blow the scale up so I don't miss any specific details. So it's a really good way of being able to gather all the details for maybe something that is busy, some kind of busy diagram. Like I mentioned earlier, this is by no means all of the symbols that we will see, that we have seen, but these are some common ones that you will see quite often. And I'll go through a couple more once we kind of hit those topics. There are a couple more in the PowerPoint that are relevant. Give me just 1 second. I just need to plug in my headphones. Okay, there we go. Alrighty, so next up is being able to use relations. So I kind of talked about it a little bit earlier when we were talking about the idea of using like the Pierce function, or relation, I guess I should say. But I mean, relations are awesome. They're a fantastic way of making sure that there's some element of consistency between adjoining arcs or edges. So just remember, in order to use relations, you're going to want to, generally speaking, assign them to 2 or more entities. So I always like to just hold the control button down and then left click the 2 or more arcs, edges, what have you, that I want to create some kind of a relation between. And then whatever dimension or whatever relations are appropriate will show up on that left hand side under the add relations bit. So SolidWorks is kind of smart in terms of making sure that uh, any relations that can be assigned will show up. Occasionally, if you select too many things, there's only so many relations that can be assigned. So you want to make sure that, I mean, however many things you're adding, it's not going to be too egregious, or else it's not going to be able to assign maybe the correct relations that you want to. And last, at least in terms of general housekeeping, arcs are awesome, just like relations. They're pretty awesome. Uh, I prefer them so much more to splines, and I'm glad I haven't really seen you guys use splines too much. Um, and hopefully, by and large, it stays that way. Splines are just really tricky because smart dimensioning them doesn't really take too much into account with regard to a radius of curvature, and it mostly takes into account the length of that spline curve as opposed to the radial aspect of it. So they're a lot more finicky and they're a lot harder to control. Arcs, on the other hand, are fairly intuitive. You have two endpoints of what could be a circle, and then you have whatever radius is given to that. There's other tools. My personal favorite is the 3-point arc. That's just me, but a lot of the other arcs are very useful as well. There's a time and a place for them, is kind of the general idea. Also, one thing to keep in mind, and this is kind of tricky occasionally with regard to arcs, even if we have certain dimensions assigned to an arc, the center of that arc, or rather the circle that could be made from that arc, is important as well. So don't forget to smart dimension the center of that arc, or center of the circle that that arc is making as well. It's probably one of the more common issues that people would tend to experience because they're looking at it and they're saying, I don't get what's going on. The two ends of my arc are aligned. I have a radius value assigned as well. What the heck is going on? There are occasions where just because you have all those details, the center is technically undefined. So that center could be moved around a little bit, which would influence what the geometry ends up looking like. So if that means that you just have to say, screw it, I'm just going to use my fully defined sketch option and just see what's going on, see why things aren't fully defined properly, so be it. But just keep that in the back of your brain that the center is also something that you need generally to define as well, if it isn't already kind of lined up with something specific.
I actually do have one question
Go for it.
about specifically about this about arcs.
Yes.
Sometimes, I mean, I don't really see you have any issues with it. Sometimes when I'm like trying to get an arc to go a certain way, I feel like it usually starts off going the opposite way I want it to, and I really don't see you having that. Do you understand what I'm saying?
I think I understand what you're saying. So here's what I'm going to do. I'm going to flip on over to SolidWorks real quick. I believe I'm still streaming. I think I am. Yes, I am. Cool. Um, so I think the two important things are, for one, it kind of depends on what arc you're using. So if you're using different arcs, they might give you different. Uh, they'll be temperamental in different ways, I guess I could say. Um, with respect to that, generally, if you're going to create something, uh, the 3-point arc, and this is why I really like the 3-point arc, because not only are you assigning the start and the end point of that arc, but you're also playing around at least via kind of like, because it has this like central, what's the word that I'm looking for? An axis of symmetry. It's creating an axis of symmetry between the two endpoints, and it's just saying that the center of that circle is going to be somewhere on that axis of symmetry. Now, that's not to say that this will still be fully defined in some manner. So what I did here is now the center is actually a little bit higher than this line. Whereas if I put this center directly on the line, I would have very little issue smart dimensioning this. So if I smart dimension this and I just say, let's say it's 37.5, it technically is saying that it's fully defined, and that's because it is aligned with the center, but I would be a little bit careful because occasionally this might get angry. It might say, well, I don't know where this is supposed to be. Better yet, what I'm actually going to do, I'm going to see if I can delete. Okay, fine, you're gonna act like that. That's okay. I'm just gonna throw this into nowhere. So something like that. So even now, if I smart dimension it, and I'll keep it as like that 37.5 that I had before, it's nowhere near defined for a couple of reasons. One reason is that even if I assign some dimensions to the center, it's still saying that it doesn't really know where this point here is. And I might... Yeah, like right here, if I click on it, it knows that it's going to be centered around this point right here, but this point right here has no relation to any sort of x and y coordinate. So I would have
Mm-hmm.
to define some sort of vertical and horizontal frame of reference if I wanted this point to be defined. So the other important thing, which I kind of hate, but so it goes, is that even though this line here is black, it's still saying that it's underdefined, and that's because this point right here, even points themselves, unfortunately, can be underdefined because it doesn't know where this point is technically located. So if I give it
Okay.
a dimension in that direction, I didn't even need to do anything else. It fully defined it because it knows if I start giving more to this line, it's going to increase or decrease that distance, or if I take it away, it's going to increase this measurement right here. So it's just by doing that, it's locked in place. I mean, if I wanted to, I could literally delete this and do the same thing in the vertical direction, and it should fully define it as well. So even just adding one more dimension to it made sure that it was properly defined. Did that kind of
Mm-hmm.
answer your question?
It did, yeah. So
Okay.
just to make sure, you said you generally like to use the 3 point.
I think the three
Is it
point arc is
okay?
the master of all arcs, but that's just me
Okay.
personally. Everybody has their opinion. But I think it is probably one of the better ones. That's not to say that tangent arcs or center point arcs are bad by any stretch of the imagination. I just think that usually when I look at a problem and I look at something and I say, how am I going to create that arc? If I see two endpoints, I'm going straight to that 3 point arc. Um,
Hmm.
Center points are pretty cool as well. So they're a little bit more finicky, so you kind of want to be a bit careful, but you can really just say, hey, I know where my radius, or rather I know where my center should be. I know what my radius value is going to be, which means I can just kind of create geometry accordingly. So if I want to create kind of like an arc just around here, I can just say I'm starting it, or it's going to be some distance from this bottom left corner. It's going out some distance, and then I'm only making sure that it's a quarter turn. So something like this, I mean, I might be able to do that with a 3 point arc, but it's kind of harder to do. I mean, that's totally
Hmm.
fine, but right now it's not even grabbing a measurement in the vertical direction. So I'd kind of be SOL. Um, and that's kind of why like center point arcs are also great, or even using like tangent arcs as well, because you can just say, oh, whatever. No, shush. You can just say that it's going to have to curve around in some manner or another. These are actually pretty
Hmm.
cool because it kind of adjusts things as necessary. It understands that, hey, if it has to be tangent, that means that it's going to have to curve in one direction or another. So it's already going to kind of take that factor into account. Then you can get things that kind of look like splines but are better. Hopefully that clarified things at least a
No,
little
yeah,
bit.
definitely. Yeah.
Perfect. All right, so back to the lecture. And as here's my stupid humor, just kind of the meat and potatoes of everything that we've gone through. So we have gone through a ton of different features. So I'm not going to go in as heavy depth as I have in a lot of the lectures. Sorry to anybody who might be viewing the lecture recording after, or this recording after, but that's kind of why the lecture recordings are there. This is primarily just to kind of think about when should I be using some of these specific features. This is kind of more of an open dialogue. I want you guys to kind of consider some of the different times that you could really use a lot of these features, or instances where you might want to use these features. Obviously, some of these initial ones are just like, well, no duh, I'm going to create an extrusion or I'm going to revolve a sketch, but obviously that kind of uh, degrades a little bit more when you're considering things like fillets and chamfers, hole wizard, sweep and loft, because those things are far more specific with how they operate. So, I mean, a basic extrusion, there's really only so much you can do with it. I mean, there's a whole lot that you can do with it, but I mean, you're not going to be able to effectively uh, create something that the hole wizard can do from scratch using extrude cuts or revolve cuts. It's going to take you way too long. So first and foremost, we have our extrude and extrude cut. So as you guys are all pretty well aware by this point, the extrusion feature or extrude boss is really just saying, hey, we have some base sketch. I don't care what it is. It could be simple, it could be complex, but we're going to give some kind of depth to it. So when can you really think about any time that we would be using extrude or extrude cut? It can be very simple, doesn't really have to be too exaggerated. Anybody at all have any ideas? Nobody? That's okay. So,
I just anytime we have to make something come out of like a design or a shape or a plane, that's when we're
pretty much. I mean, very simply put, anytime we really have any sort of uniform sketch that's requiring some sort of depth component to it. So, I mean, as we're all aware, I was about to say we should all be geometry experts, but I can't even claim that because I'm not. But we all kind of know that we need some sort of depth to create a three-dimensional object. So extrude and extrude cut is going to be our at least one of our methods of doing something like that. So anytime we have some sort of three-dimensional object that has depth, or perhaps maybe some kind of uniform sketch that we might want to cut out of an existing geometry that's already there. So things to also note is that extrusions can be drafted, or kind of giving an angle to those extrusions. And in addition to that, we technically don't even need to have closed sketches when we are making extrusions. That's our thin feature aspect of using extrusion or some of the other features. I wouldn't say that draft or thin feature is going to come up very often. Um, I guess I could just say that when in doubt, just go with old reliable. Just kind of make sure that you're making a basic extrusion. Don't try to reinvent the wheel. Don't try to kind of create something too complex or accomplish too many things at once. It's okay if you have multiple features going on in one part. I want to make sure that you guys aren't like trying to do too much, or trying to do something too savvy and you end up not getting it right because of that. I'd rather you go at your own pace or go at a simpler pace and then be able to kind of scale up from there. On to revolve and revolve cut. So this one I'll kind of just talk about pretty much very similar to what we would do in an extrude cut, but as I've kind of said a handful of times, and hopefully this isn't I don't even know if this is like a real term or not, but I kind of assume it is. But I've been using the phrase radial symmetry. So anything that when you revolve it around a central axis, whether that axis be part of the sketch itself or an axis of revolution that you create based on other geometry, you're basically, I almost said sweep, but it's not entirely unlike sweep. You're basically revolving that sketch around a specific axis. Or similarly, you're cutting out a specific profile that has that same sort of radial symmetry for that shape itself. So I mean, anything that has, or anything that is equidistant from a central axis, your revolve or revolve cut is generally going to be where you go from there. So kind of like what we talked about before, that example with the two stacked cylinders, sure, you can totally use uh, a revolve for that, or you can use an extrusion. Whichever is up to you. That is one example where revolve cut would do quite nicely. Um, it's certainly not the only example, and I'm sure there will be other times where you guys look at a problem and you could say, "Huh, that looks cool. I could make like a third of that sketch and then just revolve it around an axis." So those are kind of your general times when you would want to use it. Um, Datum planes. So I've kind of eaten my foot over this one because here I thought we wouldn't be using datum planes as much as we might need to, and disregarding your three primary datum planes, your front, your top, and your right planes, we actually use these a whole bunch, just because occasionally there's geometry that we need to make that's really too difficult to make without a datum plane, or rather, it's just straight up easier to make it if we use a datum plane instead. So in terms of how we create datum planes and when we should use them, so I know that's a big question, or there's a lot to both of those questions. But in terms of just breaking it apart one by one, how do we create datum planes? There's a ton of different ways, and y'all can just shout them out if you can think of any of the different ways.
So you just select like whatever plane, like the front, top, or right plane, and then you go to reference geometry.
Yeah. So using geometry that already exists, specifically uh, your primary datum planes that you already have, those are great to use. Uh, faces. Faces as well are fantastic for creating datum planes off of as well. And even if we're thinking of more simpler geometry as well, edges and vertices. So uh, vertices and kind of specifically vertices are actually kind of cool to use them for, because we have that like project it normal to your view option if we select a vertex. So I mean, I wouldn't say it's as precise as it should be, but depending on kind of how you're viewing that vertex, you might be able to create some pretty unique datum planes based upon a single vertex, as opposed to kind of banging your head against a desk and saying, why doesn't this datum plane uh, create properly, or why is it saying that it's overdefined? But two edges, so whether those edges are intersecting or if they're just parallel to each other, that's another way that we can create datum planes. And in terms of when to use datum planes, well, I mean, when don't we? I guess is one great thing you could say, or one thing you could say to that, is that we use them for a lot of our different features. So if we're just kind of talking about the different features that we might be using, that may or may not require datum planes, but datum planes could be used in those instances, would be tons of our features. So mirror, rib is fairly good using, or fairly useful or using datum planes is fairly useful when using ribs. Uh, it can be used if you're trying to create a helix or a spiral. It's not necessary, but uh, it could have application there, depending on if you want to create that spiral or that helix maybe on some other plane. Uh, Sweep and loft, we would use it quite a bit for, just because generally speaking, we're going to need to give some kind of reasonable or known distance, at least in the case of loft, between those kind of cross-section profiles that you're creating as it goes from one profile to another. Um, and also just kind of the precursor to all this in general is just our sketches. I mean, anytime you're creating a datum plane, well, why the heck are you creating a datum plane if you're not going to use some kind of a sketch? Or if you're not going to create a sketch? And obviously, I guess in some manner or another, I'm kind of wrong in saying that because there's plenty of times where you could be using a datum plane for other reasons. I mean, first of which, just saying maybe I want to create an extrusion on a different plane, or maybe I want to create an extrusion up to a specific surface, which is going to give it a lot different look to whatever we might be extruding in general. Um, Kind of to give at least a little bit more insight as to that without hopping on SolidWorks and just kind of showing you is, well, let's say I'm trying to create uh, some sort of a prism. So I'm starting off with a square base and I'm going to extrude it upward, but perhaps I don't want that top plane or that top face to be parallel to the base. Maybe I want it to be kind of at a slant, or perhaps at like a 45-degree angle. Well, if I'm able to create a datum plane that is 45 degrees in reference to our top plane, well, then I can just extrude that bottom rectangle upward until it hits that sketch plane. I'm fairly certain that's an option that we have. And if we're able to do that, then we're going to get something that kind of looks more like almost like a trapezoidal prism if you're looking at it from one direction. Something where your two of the sides are going to be, or two of the faces even rather, are going to be parallel to each other, but other two faces that we have are not parallel to each other. And I can kind of maybe briefly demo that a little bit later if I can get datum planes to work myself. Sometimes they can be very finicky, so that's why I don't try to uh, do things that are too excessive or too complex with regard to datum planes. Okay, we didn't really go through this too frequently, so to some of you guys, this might be like oh yeah, I totally forgot we even did that. But offsetting entities, and I mean offset entities is a good way of being able to either create reference geometry, create closed geometry from existing open geometry, pretty much making any sort of thing that has uh, any kind of like I guess again this is another term which I don't even know, or phrase rather, that I don't even know if it's like something that's commonly used, but any sort of like center line symmetry. And what I mean by that is that if you create a closed geometry using offset entities is just going to create a copy or a reference geometry of whatever sides or lines or edges you selected, which means between those two regions, between those the original and the new line or arc that it makes, there's going to be some kind of center line that runs along that entire sketch. So anything that kind of looks like it's, I guess almost in some manner or another, it kind of looks like how you would expect like shell or something to work. It just has some sort of uniform thickness as it goes across whatever the sketch is supposed to be. And I can kind of elaborate on that a little bit more near the end if need be. Um, yeah, and creating reference geometry is also great. Generally speaking, I would say if you're using offset entities, you're probably using it to create some kind of closed sketch. So that would generally speaking be a better use for offset entities, but it's not the only time that you would use it. Onto patterns, and the two different types that we had, or that we talked about primarily, were the linear and the circular patterns. So I mean, kind of as I already state right here, patterns are a great way of replicating can be sketches. The sketch pattern selection is within the sketch menu, but I would typically ask of you guys to, generally speaking, try to pattern features as opposed to patterning sketches. So when would we be using patterns in general, whether they be linear, circular, or otherwise? I mean, what the heck does patterns, or using the patterns feature, do for us?
Just when we need to create something that that's like the same shape, um, that has some type of um, like regular organized pattern to it, I guess.
Hmm. Yeah, and I like how you put kind of organized there as well, because usually when we're working through these examples, I mean, I'll reference the heat sink one that we did. I mean, there were 200 fins on that heat sink, and I don't think anybody I don't think anybody did all those by hand, because I can guarantee you it would be a pain to do that by hand. Even if you're just using like the sketch pattern feature itself, not using like the like pattern feature specifically, but using pattern sketches, it'd be such a pain to go through all of that anyway, because it's just going to take forever. So I mean, the idea here, as we're all fairly aware, is we're trying to reduce the amount of workload that we have, as opposed to increase it in times where there is a tremendous workload, or rather a larger workload. So anytime we have some sort of uniform or organized pattern, or rather feature, that is moving in one or more directions, typically two at most directions. Similarly, we can use our circular pattern. So anytime that there's some sort of axis of revolution, or anything like that, where our feature is some distance from that axis of revolution, that's a great time to use your circular pattern. Um, Something that I didn't even think of while I've been doing some grading lately, is that I think I saw somebody who basically created their axis just designating the half circle, or kind of like a part of like a cylinder, which I totally forgot that that was even a thing, that you could create an axis of revolution that way. You can literally just select a circular face, and then it'll create that uh, in an axis where the center of that circular face would be automatically. And that's a fantastic way of doing it, as opposed to creating a sketch circle, or possibly seeing where like certain planes intersect or certain lines intersect, and then creating one from there. So I mean, there's all sorts of different ways that, like I said, no way that I'd be able to look at something, or look at 20 to 30 some uh, assignments from you guys, and say, oh yeah, all of that was trivial to me. I knew you could do all those things. Like every single time I'm grading your guys' homework, I'm just like, oh, that's super cool. I didn't even think about that. So mirror. Mirror is very self-explanatory, but mirror is just going to be our way of reflecting specifically certain features over specifically a flat surface or face, or a datum plane. So keep that in mind as well. Sometimes if we're mirroring certain things, uh, we can use a datum plane that might not even be specifically aligned in any respect with that geometry that we're trying to mirror. So any time we have any form of symmetry, usually on our diagrams indicated by some dashed line, you could also consider the cross sections sometimes, not always, but sometimes, to be an axis of symmetry. Um, but kind of what I state in the PowerPoint on like the second slide for mirror, I just want all of you guys that are here, and anybody who might be watching later, to really consider how many of the assignments that we could have used mirror for. And I mean, spoilers, it's probably going to be a whole lot. I mean, the button example, heck, homework 5, the lock, you could definitely use symmetry there. It might not be the most optimal way of doing it, but you could. You hypothetically could use symmetry for it. Um, the screw that we had, what the heck else? I mean, I could go on, but I think you guys kind of got the memo. I think the only one that's kind of I'm immediately thinking of, where it's just like that really wouldn't have worked with regard to symmetry, would have been like the what's it called? That like very first one, where it was kind of a bunch of like just extrusion and extrude cuts, which had virtually no symmetry to it whatsoever. It's really the only one that I can think of where mirror would have just fallen flat. But I mean, I'm kind of harping on it a whole lot, but does that mean that it's always useful and that we should really always use it? And I mean, to that I would say, well, it really depends on what you're trying to do. Um, if you have complex geometries, and how should I put this? I obviously for someone who has done it for a little while, nothing that I've come up with has been too crazy. Um, but symmetry could be used in some of those cases. Would I use mirror for some of them? Maybe one or two, but I don't think it's always optimal. Um, I think for more complex geometries, where you're saying to yourself, creating that on both sides or both sides of that sketch looks terrible to do. Those are times that you might be saying to yourself, maybe I should just mirror this. Maybe I should cut my workload in half and just create half of this right now. And if I create half of this right now, so long as I'm using mirror properly, I'm done. I just need to select things accordingly, and thankfully SolidWorks will just do the rest. Okay, so next up is fillets and chamfers. So most of the information here, or at least part of the information here, is more kind of background as to why we use chamfers and fillets, or at least more specifically for fillets. So usually you'll get, at least if you guys are doing design projects or anything like that, or I mean if you just kind of have a general idea about how things like stress and strain and how like stress risers kind of occur, any sort of regions of higher stress, they're typically going to be along edges. Well, then how the heck do we deal with this? Well, we can use fillets and even sometimes chamfers. So fillets are excellent because we can just say, hey, this is going to be a rounded region, which means your stress risers are significantly going to be reduced in those places. Kind of a little bit of background just to kind of reinforce that idea there. A lot of my thesis work deals with like mandibular fixation devices. So I'm working a lot with like little tiny like metal plates that they put in people's like on their jaws and cheeks and stuff like that. So generally speaking, I mean, I'd ask this question to all of you, and it can be by and large a rhetorical question, but do you really want something that has a sharp 90-degree edge made out of titanium in your cheek, regardless of the size of it, even if we're only talking on like a unit millimeter scale? I know I wouldn't, because if I push on it and if I push hard enough, it's probably going to hurt. That's probably not ideal for healthcare. So generally speaking, you're going to want to make sure that things have rounded edges to them. Obviously, it depends on the application, but fillets are pretty important and can be pretty important in manufacturing. Similarly with chamfers, though I would say fillets tend to dominate, but chamfers are a great way at making sure that we're taking some sort of sharp edge that already is there, and narrowing it down so we end up having something that is less egregious of an edge. So usually your chamfers are going to be characterized by either a distance and a distance, but more often than not a distance and an angle. So anytime you see something that has a distance and an angle in one single measurement on a diagram, think about chamfers. That should be one of the first things that comes to your brain. So I kind of gave away that when to use aspect of it, but just like what I say here, anytime you see some sort of sharp edge that's being replaced by a shorter distance in addition to an angle, that's generally where you're going to see a chamfer happen. Similarly, anytime you see where there possibly was a vertex or edge, and now it's a curved region, those are going to be where your fillets uh, are shown or are prevalent. So Usually these are always going to be characterized by having that R right in front of the actual value itself. And you can have I know that sometimes if you kind of look at the shape that we have here, uh, you can, if you have kind of like that corner, you can assign a fillet to that as well. It'll kind of make it almost as if it's like, how would I even put it? Like, I guess you could say like an eighth of a sphere, like like kind of a one. It wouldn't even be a hemisphere. It'd be one part of a sphere that you're kind of slapping onto a vertex or a vertice, as opposed to just it being rounded in some manner or another. And typically when you get stuff like that, if you have that element there, usually the connecting edges will also have a fillet to it. Doesn't make sense to have a fillet on a vertex without the adjacent edges also having fillets to them as well. Okay, the hole wizard. So, this guy, there's a lot here, and hopefully it isn't overwhelming. Hopefully by this point all of you guys are at least comfortable using the hole wizard. But as we're already aware, and kind of like what I discussed when we first talked about it, is that the hole wizard is going to be a fantastic way of creating some of these more complex features, specifically complex screw holes, without explicitly making them by hand. It would take, I don't even want to generally think of how long it would take to create one of the designated holes that it already has from scratch. Like, I can kind of piece together in my head how I would do it, and that's a lot of work. So, I mean, pretty broad question, kind of already answered, but when would we really be using the hole wizard? Anybody?
For screws?
Yeah, so generally speaking, if we have anything that kind of would resemble where a screw would be, um, beyond that, like any sort of complex hole that we might have. So I'm being an idiot on the PowerPoint, but anytime you see like a stupidly long hole cut out, or call out rather, you're generally speaking going to want to use the hole wizard for that. And I mean, I know there's a lot to what's going on there with regard to what that specific call out is saying. Um, but if we take it a piece at a time, just kind of like how we should do everything, we shouldn't try to rush into it head first and try to tackle every little bit of it at once. We should piece it together bit by bit. Uh, Bart, since you just got here, just for a little bit of info, we are just going through the PowerPoint, and we are on slide 24 right now, which talks about the hole wizard. So if we're just sort of like dissecting what's going on with regard to this hole cutout right here, let's take it a piece at a time. So kind of similar to what we talked about earlier about anytime you see like a number and then an X next to it, that's just indicating that we have, in this instance, 7 times whatever this specific hole is going to be. So we have 7 of these holes. I don't really know what the orientation is or how they're laid out, whether they're in a linear pattern, whether they're circular. Usually if you see a hole call out like this where it's actually saying that there's a specific number of those holes, it's an indicator that there was some kind of a pattern that was used. So that's kind of a good little hint that anytime you see a number X, it's telling you, hey, not only do you have this hole here, but it was patterned some number of times in whatever the orientation is, whether it be circular or linear or what have you. Now going beyond that, now it's telling us that we have a 2.44 diameter that has a depth of 14.27 millimeters. So this distinction is a little bit important, or rather, this distinction compared to the next one is important. And the reason for that is because now we have a symbol that I didn't reference before, but I think most of you kind of have at least somewhat of an idea about. This V shape, this larger V shape that's pointing down, indicates countersinks. So think about a sink, how it angles downward to a specific vertex. That vertex at the very bottom is like the hole in our sink. So that's kind of the direction that the very top of that screw hole is indicating. Now beyond that, now everything that comes after that is indicating features about that countersink head. So now it's saying that the outer diameter of that countersink head is 4.37. And that does make sense, because why would the head, if we're assuming that that 2.44 is the head, why would the head of the screw be smaller than the body of the screw in terms of diameter? It doesn't make sense. So hopefully that kind of at least makes a little bit more sense, saying, okay, I know this larger diameter relates to the head diameter. Now it's saying, okay, well, that diameter is 4.37, and it has an angle of 82 degrees. So we're not always going to get an angle. I mean, for countersinks, of course we will, but for things like counterbores, we might not. That's just a counterbore might give us just another depth value, because think about it like this. Counterbore is really just, I mean, that's probably the simplest one to create by hand. It's really just going to be two extrude cuts of different diameters and different depths. So in this case, it's indicating that the angle at which that head is at is 82 degrees. Now, thankfully, we don't typically have to mess around with like the tip angle at all. SolidWorks accounts for that. The only time we would have to mess with that at all would be if we're actually, if we're actually changing up that value itself. Generally speaking, we don't have to do this, or it's not entirely necessary at all. I believe, I don't know this for certain, but I believe that if that measurement was changed, then it would give some sort of a angle or degree after the 14.27. But generally speaking, we won't need that. Okay. Moving along, since I want to make sure that I'm not taking up too much of your guys' time. So shell. So shell is a great way for us to carve out a portion of our geometry. So sometimes we do want to be a little bit careful with shell. And I actually just remembered this now, and I'm glad I'm recording things, so it'll at least be, the record will show that I didn't miss this part. But just to go through what's already here, the original face that you select for the shell is going to be considered open. Any faces that are selected beyond that, if you are using the multi-thickness option, will designate a thickness of that specific side. So if you click several faces of the general shell option, it will make sure all of those faces are open. If one of those faces is selected using the multi-thickness option, that will not be open. That will still be a closed face. It will just have a variable depth to it, or a variable thickness to it. Now, the thing that I did want to point out, and I've said it I think for 2 lectures now, and I don't want it to escape this mini lecture as well, is order matters. Order matters, order matters, order matters. The reason I say that is that if you try to do, say, 2 extrusions, I guess you could say like a cylinder on top of a box, and then you shell the bottom, that cylinder on the top will end up being hollow as well. Now, if you create the box first and then you shell the box from the bottom, and then you create the circular extrusion on top, that cylinder on top will be, why am I blanking on an opposite of hollow? But it will be full. It'll be solid. Duh. It'll be a solid cylinder. So that's something that I want you all to take into account when you are doing shell, and some with some of these other features, but specifically with shell, order matters. Now, when we would be using shell, anytime you have something that might look like this, anytime you have some sort of thin walls that are going on with whatever geometry you're working with, or possibly maybe some walls are thin, but others are not. So complex geometries can be shelled as well, but the important thing to know is that generally speaking, you want to make sure that whenever you're using shell, and especially if you're playing around with more finicky geometries, you're not getting too crazy with how you're doing any sort of multi-shell thickness. I would urge you to always try to just do a basic shell first, unless you know for certain that a multi-thickness shell is warranted. Now, something else that I've added here is that you can shell complex geometries. I want you to think about that, definitely between today and tomorrow. Complex geometries can be shelled as well. Now, to that end, or to that point, you also want to make sure that you're not exceeding any radius or radii of curvature. I know we kind of had a little bit of a discussion about this with regard to kind of like the, what was it? The hydro flask. I say as I'm holding mine. Jeez. It's been a long day. With the hydro flask example, you don't really want to create a shell that's thinner than the smallest radius of curvature on your part. And the reason for that is because if you're trying to create one that's thinner than that, sometimes it might say, dude, you're trying to play around with the geometry or ask a little bit too much of the software. Now, there's obviously a time and a place occasionally when you create those shells. Sometimes it will create an inner fillet, assuming that the radius of curvature on the outside is greater than the thickness of that shell. And I can kind of talk about that a little bit more later if anybody wants to, or if anybody has any questions about it. But you want to at least be careful with the thickness of your shell if you have very tiny measurements that are already existing on your geometry itself. Next up is the rib feature. So I have a little example right here where, I mean, generally speaking, if we are trying to use our rib, it's going to create some sort of an extrusion onto an existing geometry based upon a sketch that we would make from either an existing or a created sketch plane. So the cool thing about rib is that your sketches can be open or closed. It really depends on what you're after, though. And that's kind of the tricky part about using rib sometimes. So depending on what you're trying to do, rib can be a pain. So in terms of this diagram right here, and I should have taken a better picture of it, but that plane 2 that you see is some distance away from the parallel face. And that blue line is on plane 2. So I ask you guys, will that rib properly? Will that actually create a proper rib? Yes or no? What do you guys think? Let's talk about it a little bit. Any thoughts as to whether or not that will rib properly? If you're not too sure, that's okay. This is probably, I would say, in terms of understanding some of the little nuances of how rib works, this is one of the trickier ones. So I guess if we're just moving on, if nobody really can think of anything, then it actually won't. And the reason being is that even though, despite the fact that that line is only some distance, it's technically speaking a smaller line than, I guess you could say, like the depth of that box, that cube that we have there. Despite that being the case, the way that rib actually functions, it's is that it's extending that line even further than where the endpoints are, which means it's going to create that extrusion perpendicular to the face that's given, and it's going to do that more and more and more and more and more, and then it hits the edge. And there's nothing that's confining that sketch there, which means the second it hits like the left or the right hand edge, it's going to say, uh-oh, now I'm extruding to infinity. Can't do that. So unfortunately, there's not always a time and a place where we can use rib. Now, nicely enough, closed sketches actually work very well, because it knows that the thickness, or rather the extent of, say, that circle, that circular profile that we see on the right, it's not going to go beyond the bounds of that face, which means it's going to say, okay, I have some circle, it needs to be some given thickness to it, extrude from, it's kind of hard to see, but plane 3, which is angled to a certain degree, like 45 degrees or 30 degrees from like that top angle, and then go until you hit the geometry, and then you're able to stop. So closed sketches actually tend to behave better than open sketches. Or rather, open sketches for ribs tend to, or closed sketches for ribs tend to behave better than open sketches for them. I guess the best way that I can possibly phrase it is that for an open sketch, if I wanted that line to work, for it to be bounded, I would probably have to create little extruded edges on both the left and the right hand side of that face for that sketch. And then it would go out more and more and more and more and more, and then it would say, okay, it shouldn't exceed this wall that's already here, which means I need to stop here. And that one I actually do want to verify, just in case, because I want to make sure that I'm not bold-faced lying to you guys. So I'm going to flip on back to SolidWorks, and I think I may have stopped screen sharing, so I'm going to share one more time, just to make sure I'm not telling lies. So let me get rid of some of this stuff that we have here. Yeah, anybody can kind of tune in so as I just kind of prepare this a little bit more. So I'm creating an extrusion. And then let's say I want to create a datum plane off of that face. I'll bump it up just a little bit more. Good. And then two things that I'm going to do. I'm going to sketch on this plane, and I'm just going to create a basic line, kind of like what we were talking about. I didn't do what I thought it was going to do. I'm going to use a midpoint line, because why not? So we'll do something that looks like that. Don't really need to define it, but just as proof of concept, I'm going to now go to rib, and I'm going to change the direction so it would intersect with the geometry here. And I'm going to bump this down just a little bit more so it doesn't yell at me. Let's do 1. And it can't do it. It's telling me, hey, it's not bounded properly. Fix it. So let's actually try this. Let's try to do a thing. So I'm actually going to try this. I'm going to do a thin feature. So I'll give it some sort of depth to it. Just by going here, I'll extrude it. Not what I wanted. I want to do a thin feature. So now, kind of make it go down a little bit more. And then I want it, sure, it doesn't need to be too crazy. I'll say 5. I'm actually going to do like a mid-plane just so it comes in contact and creates a single geometry. Cool. So we have this thing here, kind of looks like a trash can. Pretty sweet. Let's see if this actually works. And hopefully does. So I'll rib that. I want it going downward towards our geometry, and it still doesn't work. So I think actually what we would need is, I think that this sketch would have to have walls high enough such that it would even be bounded, because as it's looking at it right now, even now it's probably saying, well, I'll just roll right over this edge. So let's actually try something. We're kind of doing this live here. I mean, quite literally and figuratively. I want to get this to work. Let's just put it like that. So I'll do something like that. So now our sketch is actually inside of this kind of empty region. And now, if I rib this, if this doesn't work, then I'm just going to be annoyed. Okay, now it ribbed properly. So that's a bit too thick of a rib that I wanted. So let's bump this a little bit down to like, say, 2. And now it ribbed properly. Okay, so I guess if we are kind of considering when to use rib, basically we want our sketch not only to be bounded in terms of the direction that it's facing. So I wouldn't want that extrusion line, or that line that I wanted to be extruded, over here where there's no geometry, but I also want to make sure that it's bound as well by like the left and the right hand edges. I guess you could say kind of the edges that are perpendicular to the thickness that it's going to create. Because it has to extrude outward in some direction as well, and if there's no geometry here, if there's no part here that's either on the same level or larger, or rather higher up than where the sketch already is, it's just going to run right off screen and then start trying to extrude outward into infinity, and that's not actually what we want. So I guess hopefully that kind of cleared up using the rib a little bit more. I mean, heck, even rib is a tricky feature. So I mean, hopefully this kind of cleared things up, at least a little bit. For the time being, back to the PowerPoint. Let's see. So yeah, anytime you kind of have any sort of angled extrusion that might be going towards our geometry, that's generally a good time to be using the rib feature. And this is going to typically pair nicely with datum planes. I mean, heck, you just saw me use a datum plane in order to create that sketch. There's going to be plenty of times where we want to kind of create datum planes in order to use or base our rib off of. Helix and spiral. So this is primarily just going through those two different sketches. So keep in mind that when we are using helix and spiral, basically what is created is a sketch. It is not a feature. So I know it's in the features tab. That's likely why, or the reason for that is likely because it can be used as a feature, or that sketch can be used as a feature very easily for things like sweep or any other kind of extrusion type deal, but it is not a feature in and of itself. And then I guess this one would kind of be difficult to think of in terms of when we would use it, because it's kind of like, okay, well, when the heck would you need something that looks like a helix or a spiral? I mean, if you need something that looks like it, no duh, I guess. But yeah, anything that has that general pattern to it. So I gave 2 examples here where you're using spiral and helix in conjunction with each other, or rather more so in conjunction with the sweep feature. So basically just showing, hey, I can take a spiral or a helix and then just use that as the general path for a circular profile. Kind of a cool thing is that if you think about screw threads, I mean, screw threads are generally speaking going to be in a helical, I think that's a word, helix-based pattern or sketch. So there might be times, perhaps, I don't quite know yet since we're going to talk about like toolboxes and stuff like that later, but there might be times where I might say, hey, here we have something that kind of looks like a screw threading. Um, Maybe this would be useful in an instance like that. So beyond that, we have our sweep and sweep cut. So don't worry, we're nearing the end. I know this has been kind of a long PowerPoint, but hopefully it's been at least useful in some capacity. So with regard to sweep, all we're doing is we're just creating, generally speaking, more complex extrusions with a path and a profile. Just like what we kind of discussed before, that's not to say that we need a profile, but you need to keep in mind that if you are ignoring a profile, the only profile that will be acceptable with purely a path is going to be a circular profile, unless you're using an existing face as a profile. So let's see. So yeah, if all we're after is just a circular profile, all you need is that path. You don't need a profile for it, but you will need a profile if you're going to have some sort of other complex kind of look to whatever you're working with. Say maybe you want to have something that kind of looks like a spiral, only we're using a path of, say, a square or some sort of rectangular shape instead. I don't know what the heck would be the purpose of something like that, but proof of concept, uh, we'll run with that. There could be an instance where that might be the case. Then you would generally need to create some kind of a profile. Now, I was talking about this a little bit. No, that's not my next topic. I'm terrible. So the path doesn't need to be in the center of the profile. It doesn't need to specifically be right at the centroid of it. It's generally speaking going to help with geometry. If you put the center of the path, or rather the center of the profile, aligned with the path. However, it is not necessary. You could put the path on the edge. You could put the path somewhere entirely else. The issue with that is that now your profile, you're still going to need to make sure that elements of your profile in your path are aligned correctly. So in terms of when we want to create or use a sweep or sweep cut, well, anytime that we might have some sort of profile, a uniform profile that's being extruded over perhaps a complex path, or maybe just some sort of basic path that couldn't be accomplished by way of extrusion or revolve. And this is what I very briefly touched on as well when I was kind of talking about fully defining sketches and some such behavior like that. But if we are just using a basic sweep or sweep cut, we do want to make sure that everything is defined properly. However, guide curves are stupid. And unfortunately, with regard to guide curves, we want to make sure that those guide curves are, or rather, not even the guide curves, but the profiles are underdefined. The reason for that is because a guide curve is, in and of itself, assigning different dimensions to that base profile. If we have a rigid dimension for that profile, it's going to tell you no. I mean, you told me that this circle here was supposed to be 30 millimeters. Why are you trying to get me to extrude this circle such that it would end up having a diameter of, say, 25 or 50? So they conflict with one another if you try to use a fully defined profile using specifically a guide curve. If you're just using a basic sweep with no guide curves whatsoever, fully defined. Make sure that everything is still fully defined. So only in the instances of using guide curves should you leave certain elements, specifically the profile, underdefined. Even if you're using guide curves, better make sure that guide curve is fully defined as well, and just the profile is not. Okay, and last but not least, finally, is loft and loft cut. So loft is tricky. I'm not going to make any sort of excuse about that. As we kind of discussed in our lecture, there's a ton of different features to it. I could hold an entire lecture just on that loft itself, and frankly speaking, I don't even know every little bit and piece about it. There's little things that where I was looking into it and I was saying to myself, I don't have the foggiest idea what that even does. So I I want to make sure that even though I'm no expert, you guys can definitely kind of get an idea on how to use basic loft features. Um, that being said, there's certain things that I don't necessarily think that I touched on or touched on as firmly, but they're still applicable. So kind of like my second to last point here, or rather my last point before asking the question of when to use it, even faces can be used as lofts. Uh, just as how a face of the existing geometry can be used as a profile for a sweep. So I can use those same faces to be used as profiles for my loft. So in terms of when we want to use loft, well, anytime we might have two different bases that are perhaps not the same, um, but even if they are the same, maybe we want, or maybe one of those faces, despite it being geometrically the same as the other, has a different orientation to it. So as we can see in this picture, not only did I only have to create one extra profile, I was able to use a face as an existing profile for this loft, but you can see that it's totally off center, that square on the top. So it's tilted in, I mean, kind of looking back on it, it's tilted in 3D space, not just 2D space. So anytime that you have some sort of complex curves and faces where you would otherwise look at that and just say, I have no idea how I would create that otherwise. Those are generally going to be the times that you would use loft. Now, that being said, I would not give you guys an example that looks something like this. Um, Defining that, because keep in mind, that square has an angle to it, as I said, in 3D space, which means not only am I'm defining it, or I would have to define it in three different planes relative to other planes that we already have, which is, I mean, if it's a pain for me, it's going to be even worse for you guys to just figure out how to do it. So, I mean, something like that, I'm not going to give on the exam. Um, Spoiler alert. Now, that being said, I still want you guys to understand how loft works. So, spoiler number 2, there is going to be a loft example on the exam. It's not going to be worth a ton of points, but it is going to be a relatively simpler example where I feel like you guys should be able to look at it and say to yourself, okay, I don't know how to create some of those faces or some of those geometric curves or what have you without using loft or without using something more advanced. This is probably where I should be using the loft function. So quote me on that. As I already said earlier, the exam's already made, so I already am looking at that problem in my head right now and saying use loft for it. Should be one of the first things that you guys consider next to the other features that are included in that example as well. So that's the end of the PowerPoint. Hopefully I didn't go too fast. We're about like 2 hours almost beyond when we started. Obviously this is going to be posted, but now I want this, however long period of time we want to designate, to just be open questions. So this can be with regard to the exam, it can be with regard to homework, general questions, how to use general features, maybe something that I missed, anything, ask away. And if nothing is there, then we can by and large be done.
I just had a question about how the exam's going to work tomorrow.
Yeah. So kind of the
Um,
structure of it.
well, I guess that and just like the mechanics, because like typically we log into class and it's a Discord presentation.
Yeah. So what I want it to be, um, there generally speaking shouldn't be any reason for me to be screen sharing anything. Just because it's going to be you guys taking the exam. I think I clarified this before. I know the syllabus says, hey, keep your cams on to quote unquote prevent cheating. I literally have no idea how that's any sort of check and balance to make sure you guys are cheating because you can easily just look at the PowerPoints. Now, as I've said a couple times, I would ask you guys not to do that. If you're just using the PowerPoints, then it's not really showing me that you guys know how to kind of look at something like this and just be able to figure it out. That and I guess another way that I can put it, and I hate putting it in this way, but I mean, I'm only saying this because I know another one of my professors had it. So I took a couple semesters ago, I think it was either my first or second semester of grad school, I took conductive heat transfer with Dr. Zhao. And he pretty much told us, he was like, yeah, you guys can use whatever notes you want, but like if you're flipping through like 40 pages worth of notes, it's not going to help you for like a 1 to 2 hour exam. So I know it's a heck of a lot easier to just use your scroll wheel through a PowerPoint presentation, but there's only so much information that's given on these PowerPoints, and there's only so much information or so much checks that I can do with regard to you guys making sure that you're not just watching the videos while you're going through the exam. And plus, I mean, it's a 3 hour exam, and I'm giving you guys even more time until midnight. So I don't know how anybody who is underprepared and is trying to rely on the notes as well as the lecture videos would be able to kind of utilize that stuff effectively. So pretty much what I'm getting at here, structure of the exam is you guys are going to come into the classroom. I would like everybody to be there. By and large, I'm going to be muted. Everybody else will be muted. I'll give some preliminary details if anybody is really curious or any last minute questions. I can answer any of that stuff. Um, if you guys specifically want me to share my screen with regard to anything, I guess I can. Obviously not like what the parts are supposed to look like or what features I'm using. But if you guys need clarification for anything, that can be arranged. Um, so like if you either DM me or just say in chat like, hey, can I ask a question? I'll just move you and I into one of the other rooms, one of the other voice chats. You can unmute your mic, and then you can ask the question. Obviously, there's only so much information that I can give you because it's an exam and I want it to be fair for everybody. But if there's any points of clarification that need to be made, and I see that it's maybe a measurement that I screwed up, I'll make sure to not only adjust that, but to tell the rest of the class that as well once we head back into the main room. Other than that, I think I mentioned it in the announcement. It's going to be 4 questions. Reason being, I know I said there was 3 questions. I made it 4, and that's only because I don't want any given part to be packed to the gills with features. Because not only is it going to be hard to dimension for me, it's going to be even harder for you guys to look at it and decipher what the heck those dimensions are even supposed to be. Like I'm already looking at like 1 or 2 of the ones that I'm saying, okay, this is okay, but you guys are going to need to be able to look very precisely at what some of the dimensions are implying. So I want you guys to kind of look at those things and kind of think about it for a few moments, and then if it's really not clicking, sure, we can talk about it. You can just mention it, and we'll make sure to talk about it in the separate chat uh, if it's relevant to do so. Otherwise, I want to make sure that you guys are kind of looking at things and being able to interpret it properly. And if you need clarification for that, I can do that. But interpreting those things properly and being able to make the appropriate measurements. hopefully that answered it. I know that was probably an exaggerated answer. Anything else with regard to anything? Homework, in-class assignments, exam?
I had a question about assigning like materials. So once you
Yes.
assign the material, how do you double check the mass?
Good question. So, if I go back to SolidWorks real quick, let's just say I have whatever the heck this thing is, and I want to assign a material. I was just going to click something from this drop-down, so I'm going to say that it's made of nickel. Why not? Give it a nice shine. So already what SolidWorks does is it's saying that based upon the measurements that we've given it, it has some kind of volume, and the material has some kind of a density to it. So if we have a volume, if we have a density, we can figure out a mass. If we go to the Evaluate tab and then hit Mass Properties just to the right, top right of the Evaluate tab button, if you click on that, it'll give a little pop-up that gives you a whole lot of information. Now, 90% of this is really not what we're after, but if you're looking right from where there's kind of a box, just a little bit down, you'll see density, and you'll also see mass. Mass is going to be given in terms of grams, or unfortunately pounds, which pounds isn't a mass, but whatever. And then it'll tell you the appropriate value for whatever that mass should be. So, like I said, or at least on the diagrams themselves, masses are already there. Everything is listed appropriately. So, it's more so a way for not only you guys to make sure that everything is being accounted for, but also just to make sure that there's no massive or egregious flaws in your geometry. I mean, obviously, if one of you guys recreated exactly what I have here, it might end up being, so this value is 3031.45 grams, it might be 0.5 grams or 0.9 grams or something like that. Something where it's literally within the order of a tenth or a hundredth of a gram off. I'm not going to be a stickler over that. If it's reading 3029 or 3040 or something even beyond that, something on the order of ones or tens of grams greater, that might be a bit of a cause for concern. But I mean, even if it read 3031 or 3032, that's not terrible. It might mean that there's some slight measurement that's very, very slightly off, but it's not egregious. It's not something that I would be seriously concerned about, or one of you guys should be seriously concerned about. You know, I guess if I even kind of prove it right here where that was 3031 and I just change this to say like 54 and I just change this to be 75, well, then the mass is probably going to increase just a smidge. More than a smidge. It went up by about 17 units. So just changing those two things there added about 17 grams, which I would consider something like that to be, what's the word that I'm looking for? Significant. I would consider that to be a significant change in the mass. So I would be very cautious about making sure that your measurements are correct. Usually your mass, provided you have a material assigned, is going to be a very, very good way at checking your geometry, making sure that everything is as it should be. Anything else? I'm going to see if I can create kind of the thing that I was mentioning before, where you kind of almost had like a flat surface on one end, and then I believe one of your extrusion options is literally just going up to a either up to a surface or up to a plane as well. So maybe. I don't know if, yeah, a plane should count, but I could be entirely wrong. I don't know. I mean, if, like I said, if anybody has any further questions about anything whatsoever, definitely shout them out.
Can you go over making different planes like one more time? Sorry, I know you've done it like a million times.
It's okay. So datum planes.
So, yeah, just how to make like, for instance, can you do one more example of loft just so I can see it again?
Yeah.
Thank you.
So let's kind of just create a geometry here. So I'm going to do something kind of similar to what was in the example in at the very end of that PowerPoint. So instead, get rid of you. I'm going to make a circle. And I mean, technically speaking, what I did in the PowerPoint, I could have even used Loft for if I wanted to, at least part of it, because we saw that we had, I believe it's called a frustrum, which is kind of like a trapezoid and a circle almost, but I'm not even going to bother doing that with Loft. I'm just going to give this some height to it, but I'm also going to draft it a little bit. So it's going to be smaller radius at the top than it is at the bottom. And I'm going to use this face right here kind of as like the loft face that we have. So creating datum planes and creating extra planes that might be at strange angles can tend to be a little bit tricky. And that's why it's always good to sort of play around with these things and kind of get an idea of how to actually even use them. So I might want to have, say, like I could make something that's perpendicular, uh, or rather parallel to this face here, perpendicular to this top surface, but maybe I want something that's maybe a little bit more at an angle. So let's see if we can actually try to do something like that. And I will admit, I mean, making some of these geometries can be fairly tricky on occasion. So let's think about maybe how we can create more of like an angled datum plane. So I think the first thing that I might want to do is I'm just going to create a plane based on this. And nicely enough, it tells us that it's already fully defined. So it says, hey, we have a face here. You don't need to do anything crazier than that. I'm going to say that it's like 150 millimeters from that very top. I'm going to spread this out a little bit more just so I kind of know what I'm working with. Now, I probably want something that's at least a little bit more at an angle. So what I'm actually going to do, and I don't actually know if this is going to work properly. I sure hope it does, but we'll kind of see. So first and foremost, I'm just going to create a line. Sure, let's do something like this. Not a center line. Probably could be a center line, but I don't think it matters. I'm just going to create a line out here. And the way, or rather the reason that I'm making this line is I'm going to say that this is where, or this line, I want that datum plane to intersect with it. I want this line to also be, or rather a plane to also come in contact with this line. So what I'm going to do is I'm going to go to my reference geometry. I'm going to create a plane. Hopefully it allows me to just say that. And yes, it does. And it's also asking for some further constraints. So I wonder if I can just... No, it's saying that the input is incomplete. So that's not necessarily what I wanted it to be. Maybe I want to create an axis instead. I'll say that that should be an axis. I want it about that axis. Okay, so it is still asking for another reference. So unfortunately, it's not as smart as I would like it to be, but we can still play around with this. So let's consider some of the different ways that we can create a plane. So I kind of want a plane to be very similar to how we already have it. However, maybe I want it kind of slanting downwards, which would require me to create another line that perhaps intersects with this. So that's one option that I have. I could create a line that intersects with this that could, say, be perpendicular. What's nice is that I have actually a plane that does run through that line. It would be my front plane, which means if I sketch on my front plane kind of an angled line, then I might be able to make some other stuff work here. So I'm going to, once again, be normal to this, so I can kind of see stuff at least a little bit better. And I'm just going to say that I want it to be, I want my plane to basically run along this, this line. And let's just designate an angle to it as well. Let's just say that this angle should be 30 degrees. So now what's going to happen is I actually have things defined fairly well. I have two intersecting lines that when I exit the sketch, select them one more time, and then I hit plane. Are you kidding me? Oh, this one wasn't selected. Now things are actually fully defined. So it can be a little bit finicky, but I would probably say that generally speaking, you're going to want two edges or two lines to define your plane. They can intersect, they can be parallel to each other, but this is just one manner at which I can create my datum plane for when I make my loft. Another cool way that I could have done this was if I made another datum plane with a parallel line, it would have created a slanted datum plane similar to this as well. However, making the angle for that would have been trickier. So here I was able to say explicitly, I want this to be 30 degrees from the horizontal. If I created another datum plane with a higher parallel line, it would have been a lot harder to create a 30-degree angle. Are you kind of following so far? With at least how I created this datum plane here?
Yeah, no,
Okay.
I'm
Yeah, the generation of the datum planes can be sometimes pretty finicky. So I understand why these ones tend to be a little bit of a cause for concern on occasion. So now we're actually in a pretty good spot because now I can say, all right, well, I don't need these guys, so I'm just going to hide them. I'm going to hide this axis as well. So hiding them is a good way of making sure that they don't show up, but we're not deleting them. Sometimes when we delete reference geometry, SolidWorks is going to scream and yell and pout and say, what the heck, man, I was using that. So I want to now use this as a sketch plane. So I'll sketch on this, and let's choose a rectangle this time. So nicely enough, things should still be in reference with the origin. So I'll say right here. But, I mean, why the heck not? Let's actually make it right over here instead. Let's make it even a little bit more complex where it's not actually in line with the rest of our figure. It's actually a little bit off-center. So I'll make sure that these two things are equal so we have at least a nice square. But I'm still going to have to define this relatively proper. So I'm going to define this, if I could grab it, right there. With relation to the origin, so I'll say that this is 125, and then similarly I'm going to define that guy as, let's do 600. And then why are you being a pain? So this would be a time where I would just say I don't really know why it's still underdefined, so I would use my fully defined sketch. Okay, so for God knows what reason it wants to assign the center as well, even though this should be a square. But what do I know, I guess. Okay, so now we do have two profiles that we can loft from. So I'm going to hit escape just so that's not already taking that one, but I want to loft from this face to this one. So it's going to make something that looks super weird already because it's just choosing the shortest distance between those two shapes that are there. This is the thing that I really hate. This kind of green little thing that makes very slight adjustments to whatever the shape is. If you're ghost image disappears, that means that it's actually not going to work. So it couldn't find a way to create that feature. So that means that you want to make very slight adjustments to this green dot. You can change them on both, but I would urge you to try to only play around with one. You really don't want to play around with these too much unless you're taking a look at your current geometry and then you look at the sketch and you say those don't look similar. I need to do something about that. In an event like this, I might play around with like some of the start constraints just because I want it to look a little bit nicer. So maybe I want this to kind of be tangent to this face. So if I hit tangent to face, it'll make it curve a whole lot nicer. It's still going to look kind of weird on this end where it's just choosing the shortest path, but at least for this, it flows a lot nicer. Even if I did, I think, normal to the profile, it's only going to take that circular profile, but it'll at least look a whole lot nicer than whatever the heck this is. This kind of weird jutting out as like it's shortest distance kind of thing. Ah, crap, I hit escape. If I do that again, and then I do some sort of like tangent to face, and then I hit OK. So this is kind of more so what we'll end up getting. So this is a really weird geometry. I can hide these planes as well, just to make sure we don't see them, and we only see the general part itself. Hopefully that kind of cleared up, at least very basic, how Loft works. I know it's a tricky feature, but hopefully you guys have at least a reasonable understanding of kind of how it works by this point. Anybody else? Does anybody else have any further questions? All right. Well, I'm going to